Okay, so we're using factoring here to prove identities. This is question 2A, so let's just erase this, and we'll go through this question together. Oh, I didn't put QED on that last one. Okay, so we'll do it this time. I guess it wasn't a proof, really. So this one is a proof. It's saying use factoring to help prove. All right, so exact same situation. Do you see it? As the previous example, we have two terms, and there's a cos x as a common factor. So take cos x out. And when you do that, you actually divide both terms by cos x, right? That's what you're actually doing when you take a common factor out. So this becomes 1 plus tan squared x. Everyone see that? So if we go back to the Pythagorean identities, what is 1 plus tan squared x? Okay, secant squared x. Okay, so if we rewrite this, this is going to be secant squared x. And make sure you show all these steps, okay? Because I'm saying you need to show me the proof. I already know that this will turn into this. So if you skip steps and say, oh, secant x, man, there you go, look at that. Okay, well, I know that's the way it's supposed to be, and you know that's the way it's supposed to be, but you got to show me the proof. So there is another step here that you should show. And what is that step? Sorry? Divide. Okay, well, this is showing multiplication right now. So how can I show in the next step that I need to divide something? Or I didn't quite hear that, but let me show you what I would do. Okay, cos x. I don't know if this is what you said, but cos x is 1 over secant x. That's what you said. I'm sure. That's great. Times secant squared x. Okay, and so this really is secant squared x over secant x, and then of course, you know, those divide out, right? And you're left with just the secant x on top. So I'm just running out of room there. And then you have this, and you have this, and you say, yes, that which was to be proved has been demonstrated. Right? So yeah, and you could actually have done, and I didn't know if this is what you said, actually. I didn't know if you wanted to say this secant squared x could be 1 over cos squared x. Because that would be fine too. We'd end up maybe with one more step in there, but you would have 1 over cos x then, which then is secant x. So if you did 1 over secant x here, or 1 over cos squared x here, both of them would have led you to the same answer. Okay? Question number 3, this is an exercise where it says, use a common denominator to express the rational expression as a single term. Alright, so this is what we're going to do. I'm going to erase that real quick. Okay, real quick. Oh, there you go. You need to see that. Awesome. And it says, add these things. Basically means combine these two terms. Of course, they're two terms. Why? Because we're separated by a plus sign. So that's one term. This is another term. They can be multiplied or divided. That's one term. So combine them. That's what they're saying. And if this is a fraction or a rational, excuse me, we need a common denominator. Okay, so let's show that. All right, so let's just rewrite this. Sine x over cos x. What is secant x? Well, that is 1 over cos x. And this one is super easy because even just expressing this in terms of cos, we already have our common denominator there. See that? So we really don't have to multiply both terms by anything to get a common denominator. So this is actually, now that we have a common denominator, that's what's on the bottom. And we just simply add the terms on top here, see? So this is sine x plus 1. And that's really your answer. Okay? This is not a proof. This is just saying combine those terms to get a single term. So that's your answer. We've got one term there. Even though this is a term plus another term in the numerator, this is just one single term. So we're good there. Any questions about that? Okay, so here's the second question of adding, and I'm going to get rid of this as well, but this is we have to do the same thing. We have to get a common denominator. So here is where we will have to um, multiply. Okay, so watch this. We have a denominator in this term over here. That's sine x minus 1. This is sine x plus 1. You can't say close enough. Let's just add the tops. Can't do that. Okay, not close enough. So what we're going to have to do is get a common denominator. Okay, well, if you remember how you did this in elementary school, right? You basically looked at the denominators and you said, okay, how can I make these the same? What do I have to multiply this one by to get a number that I can, easily get with the other one? Or I like to think of it this way: what does this denominator have that this one doesn't have? Well, there's nothing really easy about this. You just have to multiply, sine x plus 1. This right here is what this denominator doesn't have that this one does. And so what we do to the bottom, we have to do to the top. And the same thing over here, I've got to get a common denominator, so I'm missing this factor over here. So you got to do this. Okay. Now the nice part about this, okay, there's a nice part about this, that when you multiply these out, they're going to be what? It's going to be a what? When you multiply these, they're conjugates, right? So it's going to give you a no, not a trinomial actually. Close. If they are conjugates, binomial conjugates, you're multiplying together, it's going to give you a difference of squares. So it's actually just going to give you a binomial, not a trinomial. But that's okay. So sine squared x minus 1, okay, is what you get there. So you can just write that as one term. And then up here, though, you've got sine x plus 1. That's what 1 times sine x plus 1 is. And then you've got plus sine x minus 1. And because this is an addition, you don't need brackets here. You don't need brackets. If it was subtraction, you would. And then you look at this and you say, okay, is there any way I can simplify this? And yeah, you would just say a plus 1 and a minus 1. And a sine x and another sine x. So this would be 2 sine x over sine squared x minus 1. And that would probably be your simplest version there of one single term. If we go back to the tips, okay, one of the things I didn't mention was that you should not try and manipulate both sides. Okay, just pick one. And here's the reason. Sometimes you might say, well, I'm going to change both sides when I prove, and so I can get to the answer quicker. The reality is that in most cases, you'll actually make it a little bit more difficult for yourself. So in the example that I use here is that if you're doing a proof, okay, so let me just get down to a proof, which I'm not sure what questions these are. Okay, a proof. Okay, so we're asking, is this correct? And this is super easy, but is this side the same as this side? Okay, if you go ahead and you change this side, let's say by multiplying through or whatever, and then you go around and you change this side as well, yeah, you wouldn't save any time here. But in a more complicated one, you would probably just go and confuse yourself, and you might actually miss the whole point where both sides are equal. It's kind of like this: if you're in the complete darkness out in the woods, right, and you're trying to find someone and you have no light, all you have is, like you talking to each other, or all they can do is like they're injured and all they can do is like groan or something because they broke multiple bones. And so if they're crawling around in the dark moaning, you hear a moan and you walk towards the moan, and then all of a sudden they make another noise, and it's like they're not where they were, but you're already halfway there. So now, like, okay, what was I going crazy, or where did I go? And so then you change direction, and then they end up crawling, a little different direction, and so you miss each other. You pass each other in the dark. Does that make sense? That's totally applicable to math, isn't it? Multiple broken bones in the wilderness. Okay. Yeah, what if they broke their jaw? Mm-hmm. Yeah, this person broke their jaw. That's why they can't use words. Thank you. That's that's the reason. Okay. They fell out of a tree or something. Okay. And broke their jaw and their back and 2 legs. They're moving. They're crawling on their arms. Okay. Well, you can still crawl. Let's say they're in shock. Okay. They're in shock, and their arms are not broken, and so they're crawling with their arms. Okay. That totally. That's not part of the lesson at all. Okay. Let's bring it back to focus, kids. All right. So try and just do one side at a time. Okay. I am a little curious about how 7 went for you. No one said anything about number 7. You asked about the assignment from the last section and not the present assignment. So here's the assumption that I will make as a seasoned veteran teacher. The assumption is that most of you did not do this question number 7 that I assigned from this section. Is that true? Yes. Okay. Wow. That's great. You guys had a long weekend. You didn't even do the one question I gave you. All right. Because you only had one. Oh, that's why you didn't do it, because the assignment wasn't long enough. Thank you. Thank you for the tip. I'll make the assignment much longer next time. Can we kick her out of the class? Well, I don't think you guys can kick students out of the class, but if you could, I might be in favor of that one. Okay. Okay, so this is 7b, the one you're supposed to all have done. And they're saying, hey, prove this. So really this is like, is this true? Prove it. Show me. Okay? Because it's just a... what are you talking about? I did write B. Okay, that's a B. Just a B with the tail. Okay? It's a tail. Okay, the bee fell out of the tree, broke its jaw and both its legs. Okay? So that's a bit mangled. Thank you. All right. Okay, so for this one, what do we do? Which is the most complicated side, first of all? The left side, yes, not the right side. The left side. Okay, we have multiple terms, we have multiple trig functions. Okay? So, where would we want to start here? Any ideas? Where do you want to start? Where did you guys start? Change cotangent to 1 over tangent. Okay. You could do that. Let's do that. We'll leave everything else, so rewrite everything else. This is cos, and this is 1 over tan. Okay? That's not going to be your best choice, but that's a good choice. Thank you. That would be the better choice. Cotangent is actually, it is 1 over tan, but you're going to spend an extra line of work if you do that. Okay? So what you want to do is you want to say tangent is sine over cos. Cotangent is cos x over sine x. Okay? Is that right? We're good with that? All right. So what do we end up having here? Well, this term simplifies to... Okay? Yeah, totally you guys, not any of you did this because this is not an easy one. Okay, so this is cos squared x over sine x. All right? Now, don't even bother looking at this side like, wonder what I do next. It's not going to help, okay? Just focus on your tips and your strategies. All right? What do we have? We have 2 terms here. Let's try and get them to 1 term. So what would we do if we had to add these up? This is sine x over 1 right now. I need a common what? Denominator. All right? So let's multiply the top and the bottom by sine x. What does that give me? Well, it gives you sine squared x on top over sine x. And this is cos squared x over sine x. Now you can combine into 1 term, and this is sine squared x plus cos squared x all over sine x. Please don't say this is 2 sine x. You don't add the denominators, right? You just keep the same denominator. Anything jump out at you there, like any identity that you see there? Say that a little bit louder.